Rain, fog, and darkness can reduce camera performance. So how does a self-driving car still detect vehicles ahead? The answer is radar.
Radar measures how far away an object is and how fast it's moving by analyzing reflected radio waves. LiDAR creates detailed 3D maps, while radar accurately measures distance and speed even in challenging weather. Together, they make autonomous driving safer.
If autonomous vehicles already have cameras, why do they also need LiDAR and radar?
Cameras recognize what objects are. LiDAR measures their shape and distance. Radar tells how far away they are and how fast they're moving.
No single sensor is perfect. Autonomous vehicles combine all three so the AI can make the safest possible driving decisions. What if a car could measure the distance to everything around it using nothing but light? That's exactly what LiDAR does. By firing millions of laser pulses every second, LiDAR works using a principle called time of flight. It sends a laser pulse, measures how long the light takes to return, and instantly calculates the distance. Repeating this process millions of times every.
Instead of taking a single measurement, LiDAR continuously scans in every direction. Millions of laser reflections are combined into a live three-dimensional point cloud, allowing the vehicle to understand the shape, position, and distance of everything around it in real time. LiDAR doesn't just measure distance. Intelligent algorithms analyze the point cloud, identify individual objects, track their movement, continuously update their position. This transforms millions of raw measurements into meaningful information that the vehicle can safely use for navigation.
Not all LiDAR systems are built the same. Mechanical LiDAR offers wide, high-resolution scanning. Solid-state LiDAR improves reliability with fewer moving parts. Each design has unique advantages depending on the application.
Engineers evaluate LiDAR using several key performance metrics. Detection range determines how far objects can be seen. Field of view defines the observable area. Angular resolution separates nearby objects. Refresh rate keeps the PCR environment updated as vacuum determines. Although LiDAR is highly accurate, weather conditions these as rain, fog, snow, and dust can reduce its performance. To maintain safe operation, autonomous vehicles combine LiDAR with cameras and radar through sensor fusion, creating a more reliable understanding of the environment.
No single sensor can understand every situation perfectly. Cameras recognize visual details, LiDAR measures precise three-dimensional distances, and radar tracks speed over long range. Before sensor data can be combined, every sensor must be precisely calibrated. Engineers align their positions, synchronize their timing, and transform all measurements into a common coordinate system. LiDAR also helps the vehicle determine its exact location. By matching live point cloud data with a high-dimensional system can estimate its position with sensor-level accuracy, even in places where GPS alone may become unreliable. LiDAR measurements are only the beginning. Autonomous driving software converts this detailed environmental model into safe driving decisions by evaluating hundreds of possible paths. LiDAR technology continues to evolve rapidly. Future systems will become smaller, more affordable, and more accurate while working closely with advanced artificial intelligence. LiDAR gives autonomous vehicles an incredibly detailed three-dimensional view of the world. But in challenging weather and over long distances, another technology plays an equally important role.